In calculation, there is nothing new. We have learned all these formulas before. As you know, the stress is defined by the force divided by the area. So that's the basic equation that we use to calculate the allowable load. Now, for failure due to shear load, load is expressed, if we express load using P, failure due to shear load, then the stress F and load is P and area is A. So basically we can calculate load P equal to stress times the area. So if we know the allowable stress that a ball can take is FV, we can express that using FV times the area of the cross section of the ball, which we can express by using the ball area or something like that. This FV comes from this table 19.1. Depending on what type of ball is that, we can have the allowable stress for that type of ball. So that is already found. Now, if we have total n number of balls, capital N number of balls in the connections, then this total load will be more. Now, if you have total small n number of planes in the connection, for example, in butt joint you have 2 planes, in the lap joint you have only 1 plane. So this is the number of plane, this is the total number of balls in the connection, this is the area, cross section area of the ball, this is the allowable load. Same thing, the bearing stress, you're thinking that is gonna imagine that there is a plate like this, and then a bolt here is gonna cut like this in the middle. So now the plate is weak, so it's gonna make a cut like that. So this cross section area, that is what you have to consider here. In this case, let's say this is the ball, it was cut from here, so ball was cut off. So you can say something like this, so just cut off here. So that's why you use the ball cross section area here, but in this case we're gonna use this projected area, which is the if this is the thickness of the plate, and then if this is the diameter of the ball is D, excuse me, so diameter of the ball is D, then this projected area would be dt. So the total load, the plate load or weak plate or bearing load, let's say express that pp, we can calculate that using the area, which is dt, times the allowable load times the number of ball contains in the connection. So if I have one ball, then I will have just one shear area. If I have another ball here, another shear area, another shear area. So basically this N, capital N, is the number of ball in the connections, and this F, the allowable stress, that comes from table 19.2. It is given allowable bearing stress, so Fp, that is given for bearing type, depending on type of material used. So if this is the material, there are 2 types of material, common material. So depending on which material is that, this stress can be found from this table. Now this may also fail because of the tension, meaning that if you have a plate like this and have a hole, it may just cut off from here. So the projected area can be calculated like this. So imagine that this is the plate. So this is the projected area. Now the projected area, you can calculate the gross area, meaning that the total projected area, or in in actual, you shouldn't be considering this whole, so you have to subtract that whole from this gross area. That is called net area. So if we subtract the holes area, you may have lots of holes. I'm gonna have S, so holes, all holes subtracted from the gross area, you get the net area. So there are two equation is used. So PG, the gross load can be carried by the connection, is equal to the gross area times the stress. Now the allowable stress comes from this table 19.2 here is given. If you use the gross area, then you use this. If you use the net area, then you use this. So it's very simple. So if we use the net area, then the allowable would be the net area times 0.5 of FU. So that comes from here. It's already given. And out of all of these four, so this is number 1, number 2, number 3. So we'll have 4 different numbers for load that can carry this particular connections, and then of course whichever is the smallest, that you should say this connection can carry maximum that value. Oftentimes this is confused when you use the smallest number and say this is the maximum this connection can carry. Well, if you use some higher number, then it's gonna fail because of something else. We're gonna see an example and find that out. So out of all of these 4 connection, your answer would be the minimum one. So whatever that the minimum value from all these 4 calculation, from the 4 allowable loads. So that's it about the connection design.